Hey Algebra 2, Mr. Osborne. I am going to be starting your Brave School tutorial video. What I'm going to be doing is going over the same review, sorry about that, that we started in class right before the test. And I'll be going through all the problems, and you can kind of go through this at your own pace. You can watch the parts that you need, and then you can and skip over the parts you don't need. If there's something that you already feel like you're good at, skip it, and then go to the next thing. Or you can watch the whole thing and use this to help you finish the practice test that I gave you. And if you don't have the practice test, make sure you get that before you start going through this video. Okay? So let's begin. Okay, so this first one, solving equations. So again, on the test you had 4 more like this, but we're going to start with the most difficult one. Okay, so again we want to solve for x. What is x? And here we've got some fractions, and obviously that's a little bit harder to work with. So what we want to do is eliminate all these denominators. We can do that, then it makes it a whole lot easier to deal with this problem. So what I'm going to do is I'm going to cancel out all these denominators by multiplying a number to basically cancel them out. So what I want to do is scan across the whole equation and look for the largest denominator, and that's this 12 right here. So what I'm going to do is I'm going to multiply that by 12. What happens now is that the 12s will actually cancel out. But again, if you manipulate one part of the equation, you have to do the same to the rest. Now I'll multiply 12 across. Now if I multiply 12, let's say I have 12 over 3, 12 divided by 3 will give us 4. So that gives us a numerator of 4. And then 12 divided by 2 is 6. Okay, so what I'm going to do now is multiply the 1 times the 6. It gives me 6x. Now I have a whole number. Now I have 4 times 4, which would be 16. And then this denominator already canceled out, so all I have left is the numerator of 55, which is negative. Now it's a whole lot easier to work with. So now I just combine the like terms on one side. So 6 plus 16. 22x equals 55. Oops. And now divide both sides by 22. Cancel that out. And now I want to simplify this fraction here. So what number can I divide into both numbers? Well, I can right away see that they both can be divided by 11. So then x will be equal to 55 divided by 11 is 5, and it's negative, and 22 divided by 11 is 2. And there's my final result. And what if I want to check to make sure I'm right? We'll plug in that number to the original equation. So what I'm going to do is take that original equation, 1/2 x plus 4 over 3 x equals negative 55. Because this is a complex problem, so why not check it to make sure you're right? I'm going to take this value of x and plug it in here and here. Okay, so now I'll have 1/2 times negative 5 over 2 plus 4 over 3 times negative 5 over 2. Okay, so let's go ahead and simplify, multiply across. So it's actually going to be negative because I have a positive times a negative, so it'll be subtraction there, or minus. Let's see, 20 over 6 equals negative 55 over 12. And now I need a common denominator between these two, so what I'll do is I'll multiply both of them. I'll multiply, let's see, a common denominator could be 12, so I'll multiply this times 3, and then this times 2. Okay, so now I get negative 15 over 12 minus 40 over 12. And now negative 15 minus 40, well, that gives us negative 55. So we are correct. Okay? Okay, next one. Okay, now, find the domain and range, and is this a function? So this whole thing here, we want to, this relation, and remember everything is a relation, we want to know, is this a function? Okay? But first, we want to find the domain and range. Remember, domain is all our x values. So the domain, or D, is going to be all our x values. And here, it's a bunch of separate coordinates, or separate points. Okay, so what we're going to do here, when you have a bunch of points, is list out all the x values. An important thing to note here, let me actually erase these and do this with a different color here to emphasize it. Oops, okay, I didn't want to erase. Is make sure that you are putting these squiggly brackets, okay? This type of notation is what we use when we have coordinates, okay? And then for range, it's all our y values, or r. Okay, so that's going to be all the y values, 11, -4, -19. And if you notice, 11 repeats itself. You don't have to repeat a number. You can write it again, but it's not necessary. And again, surround that with your squiggly brackets, okay? And there's your answers for domain and range. Now, is it a function? Remember, the definition is for every input, which is x, which you put in, you get exactly one output. So if I plug in 5, I should always get 11. If I plug in 2, I should always get -4. Okay, so in this case, there is no repeated x value. So yes, it is a function, because x, or no, there's no input that has 2 outputs. Now let's say I had 5 down here. And if I plugged in 5 down here, 8 comes out. Well, originally I plugged in 5 and I got 11. If I plug in 5 again, I should get 11 again. But if I didn't and I got 8, that's not possible. If I plug in 5, I should always get 11. Okay, that's function. A function has one job, to make one thing, not 2 different things. It's not a random machine. It makes one thing. I plug in a 5, I should get 11. Not plug in again and get an 8. Okay, so that would not be a function if that was the case. Okay. Now, next one. Now determine the domain and range looking at a graph of points. Okay, again, domain. Again, these are all separate points, not continuous. So, again, we just want to list out the x values. So the x values would be -7. Now, in the test, I might not give you these coordinates. You're going to have to figure out what those are. If you don't know what that coordinate is, you just have to look down to the x-axis, and where does it fall under? -7. Next one would be -3. And then 3 is repeated, so I only have to do it once. Oops, sorry. Okay, now the range. For range, all the y values. So the first one is 6. Then I'll put -1. And actually, let's just do this in order. So what I'll do is let's start with the lowest values, -1. And then we'll go up to 5. And then we'll go over to the 6. Okay. All right. And the reason I only had 3 of these, even though there's 4 points, is because 2 of those points have the same y value. And the question is this a function? Okay, well, on a graph, when you're given a graph, you can simply do the vertical line test. And most of you guys already guessed it right there. I did my vertical line and it's touching 2 points. So I know is not a function. Okay? Now draw a graph that shows a function and one that's not a function. Okay, so I'll just do a simple one. Here's a line. And then one's not. Let's do a circle. Okay, so that means if I took my vertical line, it doesn't matter where I put it, I'll put it all the way along here, to the line here, here. No matter where I put it on the function, it will only touch 1 point. Okay, now let's go over here. Not a function, because in many places, and when I use my vertical line test, it crosses at 2 points. Okay, so again, if let's say I plugged in 2, not only do I get, let's say, about 6 up here, 2 and 6, but I also get, this is what, like 5.5? I also get 2 Also, the other value I get when I plug in 2 is 5.5. But remember, every input can only have exactly one output. But here, this input of 2 gives us 2 different outputs. That's not possible. And that is also just shown by our vertical line test. Okay? Okay, so next. So now, write the functions in slope-intercept form. Okay, so let's do blue. So we basically want to get this back in the form of y equals mx plus b. Okay, so what we want to do is we want this x term to be moved over to the right side of our equation because we want it to equal y. So to move that, we just simply subtract 5x from both sides. Okay, what happens is that cancels out. Okay, remember I'm subtracting because that's positive. And now you have negative 10 minus 5x. Remember, these are not like terms. The negative 10 and the negative 5. They're not like terms. So I can't combine them, I can't add them, I can't subtract them. I'm sorry about that. So all I can do is just rewrite them. So now I get y equals, and I always start with the x term, and then negative 5x minus 10. And there we go. There's our equation. Okay. Now this one, take the same approach. We want to move the x term to the other side. So to do that, I'm going to have to add 7x this time because it's negative. We want to cancel out. We do that. We're doing opposites. And again, I can't add this 7x to 20 because they're not like terms. The 20 doesn't have an x variable. And we write our x term first. 7x plus 20. And then again, we want x to be isolated. So to isolate we want y to be isolated, so we divide by that coefficient, whatever the coefficient is of y, which is negative 8. And once I do that there, I have to do it everywhere. Okay, so these will cancel out. And now I have 7 over negative 8. But in math, we always like to write the negatives on the top. It's just kind of like proper grammar. In English, proper grammar in math would be to write the negative on the top. And now I have 20 over 8. Well, let's simplify that. I divide both of those by 2. Actually, let's not even do 2, because I recognize that I can also divide 4. We want the greatest common factor. Okay, so we can divide by 4. I get 5. And on the bottom, I'll get 2. And it's a negative number, so I'll put minus. Okay, and so there's my second equation, or second slope-intercept equation. Okay, next. Okay, so now we want to graph two functions. Okay, again, simply we always start with our y-intercept, which is always the second term in a mx plus b form. So start at negative 2, and then the slope is 3, but the slope is also the same as 3 over 1. So that means I go up 3, the rise, and over 1, and I continue to do that until I have enough points that I'm happy to make a straight line. Okay, so now make my line as straight as I can, and there's my line. Okay, now for the second one, again, start with the y-intercept, the second term. That's positive 3, so I go up to 3 on the y-axis. And then it says negative 1 over 2. So I'm going to treat this as a rise of negative 1. The rise is negative 1. And the run is 2. So if the rise is negative, that means I'm not really rising. I'm actually going down. And then the run is 2, so I'm going to go to the right 2. So down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And to go back up the other way, I just do the opposite. So to going down, I go up, and then I go left. Up 1, left 2, up 1, left 2, and continue until I run out of points. And the reason I do that is so that I can get an accurate graph. Okay, I know that's not on the line, but it's a little hard to do it on the computer. Actually, let's try a little harder than that. That wasn't good enough. That's looking a little better. There we go. Okay. And on the test, please use a ruler. Okay? All right, next one. Now, write the equation of the lines and name the point intersection. Now in the test, if you guys remember, you weren't given a line, so you had to come up with your own. Okay, so let's say I just randomly made, well, actually let's first answer the question. So let's come up with the equations with both these lines. Remember, if we want a horizontal line, we follow the idea of Hoy. Okay, and that's our first one. So Hoy means that our line is horizontal, going left to right. 0 means there's a slope of 0. And then y means it's going to be y equals. Okay, so if you have a horizontal line, it's y equals, and whatever the y value is where it crosses the y-axis, which is 6. So y equals 6. And then for the second line, we use the idea of Vux, where the line is vertical for v. U is undefined, the slope is undefined, because it's going straight up and down, there's no change. Okay, and then there's x. I shouldn't say there's no change, but the change is undefined. Okay, because the run is 0, and that makes no sense. Okay, now that if it's vertical line, it's x equals wherever it crosses the x-axis. So that's the nice thing about this, is that if it's a y equals line, you know it's crossing the y-axis. And if it's an x equals line, that means you know it's crossing the x-axis. And you write that same value that it crosses at. Okay, now the point of intersection is just where these 2 points cross, or intersect, or 2 lines I should say. And that's at the same values of -7 and 6 that you just came up with. Alright. Now evaluate the function for the given input values. So remember, if we write it in this notation, f with parentheses, this means f of this number in the inside. In the inside is our input. Okay, so that's our input. Then we need to go to the graph and figure out if I plug in -6 in this function. This line is a function, just like if we had numbers like, I don't know, y equals 2x cubed plus x. Okay. If we plugged in -6, that would give us a value, give us a y. Okay. Same thing here. This input of -6, if I go along the graph where x is 6, I go up, I go to the function where the value is, the x value is -6, and that will tell me what our output is. And our output is 5 here. Okay, so the output would be 5. Okay, the other way you could look at this is the point where x is -6, the y value is 5. Okay, so same thing here. The input is 1. So here's 1, but the graph goes below the x-axis, so I have to go down to it. And here, it's 1 and -7. So our output is -7. Okay, now 6.5. We'll just go over here on the x-axis till I get to 6.5. That's right here in the middle. Okay, so then I have to go up to the graph because it's above the x-axis. Okay. And then at this point, our value, our y, our value, or our output is 6. So the output of 6.5 is 6. Okay, what's the relative maximum? Maximum, again, is where the highest point of our graph inside this little window. It's not actually the highest point because this graph keeps on going forever. But within what we're looking at, this main part of the graph, which is the most significant, this little curve here, what is the highest point? Okay, so the highest point here is this little mountaintop. You got to think of a maximum as like a peak. Okay, so it goes up to this point here. And the value there is 5. So the maximum is 5. Okay, we only want to know the y value. That's all that matters when we talk about max and min. Okay, so now for the minimum, that's the lowest point, like a valley. So down here, the lowest point in this little window of our graph, the y value is, what is that, 8? 6, 7, 8, 9. Sorry, 9. Okay? Now the increasing and decreasing interval. We want to know where is this graph increasing and where is it decreasing. So starting with the increase, going from, remember this is going from left to right. Left to right. From left to right, where is it increasing? So starting from the left, we're going up. And then it stops here and starts to go down. So this is increasing from, somewhere off to the left, and then it stops here at this point, okay? At this -6 and 5 point. But remember, we're only, when it's the interval increases, we're only concerned about what are the x values where it's increasing, okay? So starting off to the left, we're at an arrow. An arrow means it goes off forever, so infinity. And as x goes to the left, it is -infinity. Okay, and then as we go to the right, it stops here at the x value of -6, our increase. Okay, so infinity, we never actually reach an actual value. So what we do is we write parentheses around it. Okay, and then for 6, -6, we actually stop at the actual value, so we write a bracket. Just like when we write domain and range. Okay, so now there's another increase though. So we go down, and then at this point, at the x value of -1, we start to go up again. And it goes up, 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 up forever. So this increase starts at -1, but then it keeps on going forever and ever and ever to the right. So x going to the right is positive, so we go to positive infinity. And it starts at -1, so it's actually a close, or it's a point that we actually stop at, so we put a bracket, and then around the infinity we put a parenthesis. Okay? Now the decreasing interval is where it's going down. And it goes down from this point here, we're at the x value of -6, and then stops at the x value of -1. So the decrease starts at -6, ends at -1, and then we put brackets around it to to show that it's actually starting at an actual value, okay, or a finite value. Okay, now evaluate these functions, then complete the statement. Okay, so we need to evaluate these functions. Okay, so here's our statement. We want to know if I plug in -3, if my input is -3 for the f function, and my input for the g function is -5, which of these values is greater than the other, or are they equal? Okay, and we're going to use the greater than, less than, or equal symbols. Okay, so here we'll plug in -3. We'll input that, so we'll get -9 times -3 plus 4. So -9 times 3 is 27, plus 4 is 31. Okay, and then if we plug in -5 to the g function, it's 5 minus 6 times the input of -5, and that's 5 plus -6 times -5 is plus 30, and that's 35. Okay, so then we know that 35 is greater than 31, so that means the g of -5 is greater than f of -3. Okay? And that's it. Basically just plug in the value you're given and then see which one is larger. Okay, so now write the equation in slope-intercept form. Okay, so what we're given, well, first of all, our goal is that we need to get an equation that is y equals mx plus b Okay, so what you need to do here is, since you're only just given points, you want to choose 2 of them. So what I'm going to do is I'm going to choose the ones that look easiest to me, and I choose the ones that are non-negative, because they'll probably end up canceling something and making it easier to work with. So first I want to find the slope. Now to find the slope, what I want to do is take the y values, and I'm going to do the second y value minus the first over the second x value minus the first. Alright, so what I want to do here is I want to subtract y2 minus y1. So I'll go ahead and make this point the second and this the first. So what I'll do is 0 minus 3, over 20 minus 8. Make sure that's consistent. Make sure you just do whatever you decide is the second one, make it the second for both the x and the y. Okay. So now I'm going to subtract 0 minus 3, which is negative 3, and 20 minus 8, which will give us 12. And then I can simplify that, and that will give me negative 1 over 4. So there's my slope, there's my m. Okay, so now I have this, I know this much. I know y, because it's always y, equals negative 1/4 x. But I just don't have my b. I don't have my y-intercept. So what I can do is I can use the point slope formula, y minus y1 equals m times x minus x1. And so basically all you need here is a point and the slope. Okay, so I'm going to choose a point. Now I'm going to choose the one that looks the easiest. I think this 0 and 20. So I go ahead and plug in the y value for the y1. And I leave this y, don't plug in there. And I plug in the slope, which is negative 1/4. And then I plug in the x value in the second x term. Okay, and now I just evaluate it. Y minus 0 is just y. And then negative 1/4 times x is just 1/4 x. And then 1/4 times 20, 1/4 of 20 is 5. And negative times negative gives a positive. And there's our equation. Of course, the other way you can do this is you can start with, there's actually a couple ways you can attack this particular problem. Take this plus b, and then you can plug in one of the points into this equation that you have, because you know that an x and a y value, so the y here could be 0, and then an x value when the y is 0 is 20. I'm basically just using this point up here, this 20 and 0. And now I can just solve for b. Okay, so 1/4 of 20 is 5, but it's negative. And I know if I move this to the other side, it's going to be positive, so b equals 5. Okay? And that's it. Okay, now again, write another slope-intercept form equation where we're given these two statements here. This says f of negative 3 equals 2, and f of negative 7 equals negative 6. Okay, so that, remember, this first value here is our input. This is our output. If I plug in negative 7, I get out negative 6. So the other way I can write this is as a coordinate. I plug in negative 3, the y value is going to be 2. I plug in negative 7, my output or my y value is going to be negative 6. So again, I'm just working with 2 points. It's just like the last problem. So I'll make this one the second point and this the first. So I'll do negative 6 minus the first y, which is 2, and then negative 7 minus the x value, negative 3. Now this is important. If it's negative, you want to put parentheses around it because it's minus another negative value. Okay, because those negatives will become positive. Now negative 6 minus 2 is negative 8. And this will be plus, so negative 7 plus 3 would be negative 4. And that negative 8 divided by negative 4 is 2. Okay, so now I'll use the point slope formula. I'm going to plug in one of these values. So I'm going to use the first point. So for my y value, I'll put 2. And then for the slope I'm going to put 2. I'm using the same point slope formula from the last problem. And then for my x value, I'll use -3. And again, it's negative, so make sure you write parentheses so that you know you're going to have to change these two negatives to a positive. Okay, so those become positive. Y minus 2. So let's go ahead and distribute this 2. So 2x, and then 2 times 3, positive 6. And then I have to add 2 to both sides. Y equals 2x plus 8. And there's my equation. Okay, now, find the domain and range of these two functions. And are they functions? Okay, again, when you just have a continuous line or some graph, what you want to do for a domain is you want to know what is the boundaries for x to the left and what are the boundaries of the limits for x to the right. Okay, so the boundary is to the left. If I'm coming from the left, the first thing I hit is a arrow. Okay, if arrow means infinity, it means it goes on forever. So to the left, x is going to the left is negative infinity because it keeps on going forever. And if I come from the right, first thing I hit is another arrow. So that going to the right, x is positive infinity. And using interval notation, which is either parentheses or brackets, I would put parentheses because these are not finite values. They keep on going forever. And now for the range, I do the same thing, but instead of going from left to right, I go from the bottom to the top. So I come up from the bottom, and the first thing I hit again is an arrow. So from the bottom, if I hit an arrow, y going down is negative infinity. And again, I do the same thing. Come from the top, first thing I hit is an arrow. So that means on the top range, y goes on forever and it's positive infinity. And again, same notation, parentheses around both. Okay, and there's your domain, there's your range. Is this a function? Vertical line test. If I do my vertical line test, going across the whole function, it only touches one point as I go across. So yes to the first one. Okay. Now the second one. Domain. Start with domain. Let's do this in red this time. I come from the left. I always start from the left because I'm looking at what is the limit of the x values to the left. And I don't hit an arrow. I actually just touch the graph at some point. And that point for the x value is -5. So to the left, the limit is -5. And on the right, the limit of our graph, the x value is 0. And these actually are finite points. They're actually landing on some point. So here, I would note that by putting a bracket. Okay. Now for the range, again, remember we start from the bottom and go to the top. So if I come up, first thing I hit is the bottom of this graph. And the y value there looks like it is -6. And then I come from the top. First thing I hit is the top of the graph. And the y value there is -2. And again, these are both finite points. So I'll put brackets around both of them. And there's my domain, and there's my range. And now what I want to do is do my vertical line test and see. We already know for sure it's not a function because if I do a vertical line, it touches 2 points. Okay, so this is a no. All right. Go to the next one. Okay, so now write the equation in slope-intercept form. So now, before you were either given the slope, you're given a point, or you're given 2 points. Now we have the graph, and we want to write our slope-intercept form graph. Okay, so first thing we want to look for is the y-intercept. That's always the easiest one to look for. Okay, so the y-intercept is -1. Okay, so that's our b. And then we want to know the slope. So start at one point and go to the next. So how far is my rise? My rise going from, let's see, -5 all the way up to +5. Well, the rise would be 10. Like that. And then the run going from that point to going from there to there would be 5. So the rise over run is 10 over 5. 10 over 5 is 2. So then my slope is 2. So then we put 2x and y equals, and there's my equation. Okay, again here, do the same thing. First, look for the obvious, the easy one, which is the y-intercept, which is 2, positive 2. And then going from this point to this point, in order to do that, I have to go down first. And if I go down, that means it's going to be negative, so negative 4. And then I go over from negative 6 all the way to this point to positive 6, and that's a run of 12. So that my slope would be equal to negative 4 over 12, which reduces or simplifies to negative 1/3. So then negative 1/3 is my slope. My y-intercept is positive, and I put y equals, and there are my two equations. Okay. Now I'll draw an example of each parent function. A linear, I'll just quickly do this, straight line. Absolute value is a v, and you can remember it's a v because a v, quadratic, is a u, not a q, but a u. A c is a cubic, which goes up, kind of levels out, and then goes back up again. A square root function starts in the middle somewhere and starts to go up, but then starts to level out to the right. And then exponential starts out slow, but then explodes. Explodes, going to the right. Okay, that's it. Have any more questions, come and see me, finish the practice test, and then we'll take the test.